So when an ISP approaches for address to AppNIC or AFNIC or AirNIC, there are many forums. For different continents, you have different forums. When you're requesting for IP address, they will ask like, what is the prefix length you want, /23 to 32, because it's ISPs of ISP. You need to understand. So if you want really too many, then you go with 23. But for a country which has got few millions of people, 32 is enough. /32. So out of 128 bit, 32 is what they are going to mask and give you. From that 32, we will create multiple subnets. This is an ISPs of ISP. Under this ISP, there are 10 ISPs. And above this ISP, there are 5 ISPs. So totally 15 ISPs needs IP address from this ISP. This ISP need to distribute to 15 other ISPs. So /32 is enough. The number of population is not that big, like 15 million or something like that. I forgot. So after calculating, I said /32 is enough. And then the next question is, will you be announcing this address? Will you be advertising it? Will you be doing like route solicitation, neighbor solicitation, neighbor discovery, route discovery? Yes, of course we do. So punch this. Now, what are the services that you offer in your ISP that we need to fill in here? Like MPLS services, IP security, IPsec, all those things. Transit, not only transit, all extra things. Address planning, you want to do immediately, or you're planning for another 1 year to deploy. So our thing was immediate. So these are the star thing which is important. Other things we no need to put in. We did not fill it, and we have submitted it. You see, we have submitted. So we'll get an IPv6 address. All right. So this is. So before we enable any routing protocol, let us check whether we already have some routes. Show IPv6 route. Of course, we got a default route. Let me try pinging 3333::3333 from source 1111::1111. If this ping happens, then which means then it means that there's a static route. And this is the first time in my life I'm seeing one dot when I have IPv6. It is all because it is because of the GNS3. I just turned on all this device. I think it took some time to bring the device up, not because of any ARP or anything like that. Okay, you will never see the dot. Now, I want to remove the default route. Do show section IPv6 route. Nope. Likewise, I would like to remove from R3 show run section IPv6 route. No. Next is, you remember in router 2 I was typing one command IPv6 unicast routing. As a result, you see show run, the command I typed it here. You will be seeing that one right in the beginning. IPv6 unicast routing should be there on the top. Here it is. This command only will join you to a multicast group called ff02::2, meaning only this command makes this router as an IPv6 router. So the router starts supporting IPv6. Now this command need to be now given on every router because you're going to have these routers running routing protocol. See, earlier we did not type this command on R1 and R3 when we had a default route, because this was the only router which was acting as a router, taking traffic from the left and giving to the right. The other two were pinging and responding like a computers. Computers, you don't need to type this command. Like a host, they were R1 and R3. But if you want to enable a routing protocol, you see, for example, I'm going to run IPv6 OSPF. IPv6 router OSPF 10. You see, it says IPv6 is not enabled. How will I run OSPF? So what I'm coming to say is, for any routing protocol, you need to enable this command, IPv6 unicast routing. After this, you can enable any routing protocol of your choice. Now let me also do this on R1, IPv6 unicast routing. Now, as we discussed earlier, we are going to enable RIP. But I'll tell you one thing. We need to provide router ID manually if you don't have a loopback interface. So show IP interface brief. I'm saying show IP. Listen, show IP, not IPv4. To check whether I have an IPv4 address. Now I need an IPv4 address like this, so that will be dynamically used as the router ID by this routing protocol. IPv6 routing protocol needs 32-bit router ID. Same like an IPv4 format. That is why I have given this. Okay, now if I enable RIP, without any problem, RIP can run. IPv6 router RIP. If you hit enter, it won't accept. In IPv4, when we type router IP router RIP, it will accept. But in IPv6 RIP, you have to provide a process ID. So I'm going to say IPv6 router RIP. Some name I have to give, that's all. Some name. I can name it as pen. Just a name as a process ID. Now you will not find any network command here. Okay. So only you need to come here in this mode if you are planning to use any of these commands. If not, you don't need to even come here. There is no purpose of coming. You can go straight away to the interface where we usually enable IPv6 RIP. The command is IPv6 RIP pen. enable. Pen is the name of the process ID of RIP. You can run more than one RIP in a same router, and each RIP will be identified with a different name. Pen, paper, likewise. You can give any name. On this interface, I'm enabling the RIP whose process ID is pen. Now I also want to enable interface G3/0 with same process ID pen. I got now RIP running on this router, IPv6 RIP. Let us go and verify. Show IPv6 protocol. Look at this. It says IPv6 routing protocol RIP called pen is running on this two interface. Now the multicast address of RIP is FF02::9 that I want to show you. Debug IPv6 RIP. You'll see this will try to send updates every 30 seconds as usual, what we saw in IPv4. The periodic update is every 30 seconds. You see? To which address it is sending? It is sending to multicast address FF02::9. That is the destination address. Right? And they will be using source address as the link local address always. RIP or any routing protocol you take, they communicate using the link local address. And see, it is advertising networks. It is advertising the networks with the hop count metric 1. Now let us move on to router 2. On router 2, I have already configured that IPv6 unicast routing command. Now I'm going to say interface range loopback 0, comma, comma, or no need of comma. Let's do physical interface first. Interface G3/0, comma, F0/0, comma, loopback 0. Okay. IPv6 RIP paper enable. I'm running RIP on all these three interface. Show IPv6 RIP. Show IPv6 protocol. You can see a RIP protocol called paper running on this three interface. What about the router ID? Actually speaking, except RIP, all other protocols need router ID. For RIP, there is no need for router ID. See, in this router, I don't have any loopback interface. Show IPv6, show IP interface brief. You see, there is no loopback interface with IP address, nothing. But show IPv6 route RIP. You see route given by RIP. So RIP is already running. So remember, except RIP protocol, because it uses UDP, there is no need for an IP address to be used as a router ID. Whereas for EIGRP and OSPF, we need a router ID. So make it as a practice. Any routing protocol in IPv6, you provide a router ID that is better for you to avoid confusion. But for RIP, really it is not needed. Let me go to router 3 and enable RIP. Router, not necessary. Interface, range F00, comma, loopback 0, IPv6 RIP, stone. So RIP called stone is running here. Show IPv6 protocol. You have it. Show IPv6 router RIP. You see the routes. So if you see, this router 3 and router 2 don't have any router ID. Only for RIP it is not needed. Okay. So I can ping now, colon, source loopback 0. See, it's pinging. Okay. So we got how to configure RIP NG. RIP NG is nothing but IPv6 RIP next generation. The timers, everything is same like what you saw in IPv4. In the multicast address, if you see there, it is 224.0.0.9. Here FF02 colon 9. Yeah. So that is about RIP. Let's remove this RIP and put EIGRP. So how to remove it? It is very easy. No IPv6 unique, no IPv6 unicast routing. This is the command which will delete all the routing protocols in a router. Now IPv6 unicast routing brief. See, show IPv6 protocol, no RIP. Likewise on R2, no IPv6 unicast routing. Same like this, you can also remove in IPv4. No IP routing. That's the command, no IP routing. If you want to remove all IPv4 protocol, this is what? No IP routing. This command, if you type, it will remove all IPv4 routing protocol. All right, next. R1. No IPv6 unicast routing. Now we have removed IPv6 complete, so means no IPv6 routing protocol completely. IPv6 unicast routing. Now EIGRP. For EIGRP, as I said, router ID is mandatory. But the good news is we already have a loopback interface which will be taken as the router ID. So I can go straight away to the interface. Interface loopback 0. IPv6 EIGRP, the autonomous system number. That's all. And also interface G3/0. Done. Now if you verify show IPv6 protocol, there is no EIGRP running. Why? We have router ID, but still why it is not running? This is one weird behavior, weird thing in here. See, you have to go and say no shutdown. I don't know why it is like this. That is how they have designed. See, IPv6 router, EIGRP 100, you need to say no shutdown. See, you're not doing no shutdown under a physical interface. You are saying no shutdown for EIGRP process. Now if you go and check show IPv6 protocol, you can see EIGRP. And you see, as I told you earlier, there is a router ID and it is dynamically picked up from the loopback interface. All other things are same. You see, administrative distance, everything is same. Now let's go to enable, go to the other router and enable EIGRP router 2. This don't have a loopback interface. As a result, when I say IPv6 EIGRP, IPv6 router EIGRP 100, okay, IPv6 unicast routing 100, and even though I have said no shutdown and interface range loopback 0, G3/0, F0/0, IPv6 EIGRP 100, EIGRP will not come up. See, show IPv6 EIGRP interfaces. You see, it says there is no router ID found. How can I run? So I can give manually router ID like this, router ID, EIGRP router ID. I'm already inside EIGRP. I don't know why the syntax is like this. EIGRP router ID. So for a router ID, it need not to be there on the interface. See, as soon as I said it has found the neighbor, as I said earlier, it will always use the link local address to found neighbor. Show IPv6 EIGRP neighbor. You can see only the link local address of router 1. This is the link local address of G3/0 router. To make it easy for you to understand, what I can do is I can go to router 1 and configure link local address manually. Listen, you can configure link local address manually. IPv6 address, it needs to start with FE80::1 link local. That's all. Now I'm going to shut down so that the neighbors will be removed from the other router. Wow, it has already come. FE80::1. It has already come. Okay. So you see, it clearly shows who the neighbor is. It will come again. You see, the neighbor is router 1. I only gave FE80::1 as a link local on router 1. So using the link local address only, they form they negotiate. Let me also provide loopback IP address here so that it can be picked as a router ID. And now IPv6 router EIGRP 100, no shutdown, interface loopback 0, comma F00, IPv6 EIGRP 100. See, the neighbor has come. Now if you go to router 2, you should see 2 neighbors. And this is the link local address of router 3. Now I can ping from R3 to R1. Ping 1111:1111 source loopback 0. See, the ping is going. We have seen 2 protocols. Now let's go to the third one, OSPF. Again, as usual, I'm going to say no IPv6 unicast routing. And then IPv6 unicast routing. I'll repeat the same on R1 and R2. No IPv6 unicast routing. IPv6 unicast routing. No IPv6 unicast routing. IPv6 unicast routing. Show IPv6 protocol. There is no routing protocol. Let's enable OSPF. Router IPv6. You don't need actually. You can go straight away to the interface. Interface loopback interface range. OSPF is the easiest IPv6 configuration. Interface range loopback 0, comma G3/0. IPv6 OSPF process ID area ID, same like IPv4. That's all. All right. Now let's verify. Show IPv6 protocol. You can see OSPF is running. Show IPv6 OSPF interface brief. You can see OSPF is in the area 0 on this 2 interface. Now on R2 IPv6. First of all, I want to, okay, no problem. IPv6 OSPF1, IPv6 OSPF, router OSPF, OSPF1. You know why I'm coming here? Just to give router ID. And then I'll go under interface range loopback 0, G3/0, F0/0, IPv6 OSPF1 area 0. And here, even though they are using even though they are using the link local address to form neighbor, for negotiate neighbor, it uses link local address as a source and destination address to negotiate. But internally they share the router ID, so they use they show the router ID as the neighbor. Show IPv6 OSPF neighbor. You see, though it is showing 1111, it is not negotiating with this address. It is using the link local address. You can also see that by enabling debug IPv6 OSPF packets. You see, this is router ID. Or I should not OSPF. I should type debug IPv6 packets generally. And you see, it is using the link local address, all right, and it is using the multicast address. Everywhere it will use the link local address. Okay, right. Now I'll move on to router 3. Interface range, so interface range loopback 0, F0/0, IPv6 unique IPv6 OSPF1 area 0. Now you can see the neighbor has come and show IPv6 route. You see the route given by OSPF, and you see the next stop is not the global unicast address, rather it is the link local address of the physical interface. Let me try tracing the route. You can see it goes to router 2, and from router 2 it has gone to router 1. Trace. Okay, in IPv6 there is no source. Okay, no problem. This is IPv6. Now let us move on to IPv6 BGP. It is very simple. You see, router BGP 100, IPv6. First of all, you need to configure here IPv6. Neighbor 1111:1111. I'm forming neighbor using loopback. Remote AS 100, and then update source. All right, but this is not enough. You need to say one more command. Address family IPv6 unicast neighbor 1111:1111. That's it. As usual, you configure neighbor like IPv4 neighbor, you configure IPv6 neighbor, but you need to activate it under the address family IPv6. Let me do it on R1. Router, there is no IPv6 router for a BGP. It is a simple router BGP 100. Neighbor is 3333:3333. Remote AS 100. Update source loopback 0. Address family IPv6 unicast neighbor 3333 colon 3333 activate. All right, now you will see show IPv6 BGPs, show BGP IPv6 unicast all summary, unicast summary. You see the neighbor is there for last 10 seconds. Show BGP neighbor, show IPv6 BGP, no, show BGP IPv6 neighbor. There's no neighbor command. Unicast summary, we know neighbors. You can see here the neighbor is established, and you see the router ID. It has picked router ID 3. Right, so we have seen all routing protocols, IPv6 with all routing protocol. The next class we are going to learn some migration techniques in IPv6.